In this video, I'm going to explain to you how to find the domain of rational functions. So to explain that to you, I'm going to go back to the notes I've created for this section. So we're going to jump to the notes. These notes are available on the website if you want to download them and use them. And if you look at the main steps involved in finding the domain of a function, you'll see that it focuses on the denominator for rational functions, clearly because a rational function is a fraction, and as you know, for all fractions you can't divide by 0. So this is why in the first step itself you identify the denominator, and then in the second step you're equating it to 0, so that you try to find that value of x for which the denominator is going to become 0, and then you will end up excluding that value. So this is why you have three very clear steps. The first step is finding the denominator. So that's just looking at what's in the denominators. So here's qx. Equating the denominator to 0. By doing this, you're able to find a value of x. And then this value of x, which you find in step 2, is the value of x which makes the denominator become 0. So domain by default is all the values of x a function can take. So what you have to do is you have to say that all the values of x will actually work for this function except the one we have to exclude, which is the one in step 2. Right? So this is when the third step you tell the examiner, or in your answer you're writing that all values are possible except the one from step 2, because the value of x in step 2 is the value of x which makes the denominator become 0, and so that's the one we need to exclude. So I'm just going to do a couple of examples for you on the board, but I think in the explanation it's quite simple, so you can actually just read from the explanation PDF. Otherwise I'm going to do a live demonstration of how it should be done when you're actually doing your workings, right? So let's go to the board. So the first function we're going to explore is going to be the first example from the PDF, which is fx equals 2x plus 3 divided by x minus 1. So step 1 was finding the denominator. So the denominator here is x minus 1. So x minus 1, you equate it to 0. This is what you were told to do in step 2. So you get x equal to 1. So x is equal to 1 is that value which makes the denominator become 0. And you can quickly just take the value and replace it here. So if I take the value of x as 1, I replace in the function here, I get 2 times 1 plus 3 divided by 1 minus 1. You get 5 divided by 0. So you see it's an undefined function because you're dividing by 0. So that's the value of x we need to exclude when we're working out our domain. So the domain here will be x is an element of R, meaning it can take any real value, any value on the number line, except the value we found from step 2, which is x equal to 1. So it can be all values on the number line except x equal to 1. Let us do the second example now. So the second example was gx is equal to x squared minus 4 divided by x squared minus 9. So same thing, you take the denominator, which is x squared minus 9, you equate to 0. So you get x squared is equal to 9. So x will be square root of 9 plus or minus, so that's plus or minus 3. So these are the two values of x which will make the denominator become 0. And we can just quickly try to replace. I'm not going to write it down, but let's just do it visually. So if I take 3, I replace here, I'm going to get 3 squared minus 9, which is 9 minus 9, 0. And minus 3 also will be minus 3 in brackets to the square, which is 9, 9 minus 9, 0. So these two values don't work. So once again, your domain would be x element of R, and x can't be plus or minus 3. So it can be any value of x except plus or minus 3. All right? Let us just erase that. and we're going to do the third example for you. All right, let's look at the third one now. So the third one is 1 over x minus 2 and x plus 5. Same step, you take the denominator, which is a quadratic equation here which has been factorized actually. Equate it to 0, so whenever you have an equation in this form, you usually do either or. So x is 0 or x plus 5 equals 0. So you get x is equal to 2 and x is equal to minus 5. So these are the two values of x which make the denominator become 0. So we have to exclude them. So x element of R and x can't be minus 2 and x can't be minus 5. So that would be your domain. All right. Now, if we go back to the second example, which was gx is equal to x squared minus 4 over x squared minus 9, we had written that x was an element of R and x can't be negative 3 and x can't be 3, okay? So that's how we actually wrote it last time when we did the question. Now, that's one way of writing your answer. There is another way of writing it with brackets, which I actually showed in the explanation. I'm going to quickly show you where it is. So this is what we've done. X element of all x can't be plus minus 3. And then I've got a section here whereby I use interval notation to explain to you how you can write the domain. Okay, it's found here. So I'm going to show you how we actually come up with that. One way to easily get it is actually by trying to look at this solution set on a number line. So we have minus 3 and we have 3. Now, x can't be negative 3 and 3, but can be anything else. So what do we have here? We have x more than 3. We have x between minus 3 and 3. You see that I'm not including the 3 and negative 3. And then I have x less than negative 3. Usually when we exclude the values, let me use proper notation for you here. Usually when we exclude the values, we use a circle. You've done that in IGCSE, whereby you have a circle and you don't shape the circle when you're excluding the value. So in terms of inequality, that's the shaded region, excluding this and this, and then over there and then over here. Now, if we want to use interval notation, we'll need to say, we need to actually put the lower limit and the upper limit. So for x less than negative 3, if you keep going on the left, you go up to negative infinity. So the lower bound will be minus infinity. And the upper bound will be negative 3. Now, with interval notation, when I'm using this bracket, it means I'm excluding the bounds. Okay. If you want to specify inclusion, you need to actually use square brackets, which I'm not doing here. So x between negative infinity and negative 3, that's this section here, because it starts from negative infinity and then it goes up to negative 3, but doesn't include the negative 3. Then I have this one, which is between negative 3 and 3, okay, this section, union, more than 3, so excludes the 3 and then it goes up to positive infinity. So instead of writing it in this manner, which is just fine to me, you can actually use interval notation and write it in that way. And that's my first introduction to writing in interval form was actually in the first year of university. But in the DP curriculum, they actually encourage you to explore writing notation in this way, because it's a very formal way of writing down the domain. All right? So that's all from me for this section of the PDF. I think you can use the PDF on its own, but I thought that a visual would actually be helpful as well. Good luck with that.